Hello everyone, and welcome to this video where we are going to have a look at finding the area enclosed by polar curves. So there's this little diagram here which shows a polar function, and it shows here the area between that we are looking for between this angle alpha. So we always measure anti-clockwise from the initial line where theta is equal to 0, and this angle beta. So in order to find the area, we're going to use the formula half r squared d theta between beta and alpha, and that is going to give us this shaded area. So let's have a look at the first example where we are asked to find the area enclosed by the cardioid with equation r equals a times 1 plus cos theta. So the first thing that's useful to do is to think about what this graph looks like. In general, you will be given graphs, diagrams of graphs, but when you are not given in the specification, they do state that you need to be able to sketch graphs of polar curves. So in this instance, let's have a look at what we learned from sketching polar curves and what this will look like. So if I expand these brackets, I get r equals a plus a cos theta. And this is an example where a is equal to b, which we looked at in the second video, which we worked on. And this is going to give me a cardioid, and it obviously says that in the diagram, in the question as well, but if they didn't say that, then you know now what to look for. It's also cos theta, so I know it's the cardioid that has symmetry about the initial line. And it's going to look like this, but if you struggle in the exam to remember, well, then you're just going to plug in some key values and you can work that out. Remember, that's a and that's a, and this is going to be a plus b, so in our case 2a. So we are looking for the complete area here, and there's two ways to go about this. We can either integrate between 0 and 2 pi, and we'll find the enclosed area, or we can integrate and say we want two lots of the integral between 0 and pi. Both of them will give me the same answer. So remember that my formula says it's a half times r squared d theta, and so in each case I will need r squared. So that's the first thing I'm going to do. I'm going to find r squared. So r is equal to a times 1 plus cos theta, which means r squared is going to be a squared times 1 plus cos theta all squared, which gives me 1 plus 2 cos theta plus cos squared theta. Okay, so I'm just going to integrate between 0 and 2 pi. So it's a half times a squared, which I'm going to take out to the front because it's a constant. And I then am integrating 1 plus 2 cos theta plus cos squared theta with respect to theta. Other thing I'll have to remember is I need to rewrite cos 2 theta as a double angle. And so it's useful, if you haven't memorized this already, to memorize this now, and to remember that cos squared theta is equal to a half times 1 plus cos of 2 theta, and sine squared theta is equal to a half times 1 minus cos 2 theta, and that all comes from my double angle cos 2 theta, which is either equal to 2 cos squared theta minus 1. It's also equal to 1 minus 2 sine squared theta. So we've just rearranged those two identities. Right, so I'm going to rewrite this. So I get a half a squared between 0 and 2 pi of 1 plus 2 cos theta. And when I expand these brackets, I get plus a half plus a half cos 2 theta. With respect to theta, I'm ready to start integrating, and I know that 1 plus a half will give me 3 over 2. So when I integrate 3 over 2, I'm going to get 3 over 2 theta plus 2 sine theta plus, that should say cos of 2 theta, sorry, half cos 2 theta, plus a half sine 2 theta, and I need to divide by a, or times by 1 over a. Remember, the integral of sine k theta, or cos k theta, is always going to be, so in this case it's going to be negative cos k theta times by 1 over k. So hopefully you remember that from P4, but this is going to give me 1/4 sine 2 theta. And now I'm just going to sub in 2 pi and 0. And so I'm going to end up with a squared over 2. And if I sub in 2 pi, I'm going to get 6 pi over 2, which gives me 3 pi. Sine of 2 pi is 0. So that's plus 0, and again 0. And when I'm going to subtract 0 subbed in, which gives me that. So very nicely, that is going to simplify to 3a squared pi all over 2. And that is the enclosed area there. Okay, let's look at the next example. Here, example 2, find the area of the region bound by the curves r equals 2 plus cos theta and r equals 5 cos theta. And so we're not given a diagram, so we're just going to think about what this will look like. Sorry, that's my A, and my B is 1. So I have that A, remember this, when A is greater or equal to 2B, then I have a convex polar curve, right? So the convex polar curve was where it didn't have a sort of a dimple. It didn't have this happening. It just straightens out. And this is just a circle with symmetry, because it's symmetry about the initial line. So this is my circle. Okay, so let's sketch that. Step 1, sketch what this looks like. So I'll sketch 2 plus cos theta first. It's going to look like this. Remember, this is a plus b, so that's 3. And this is the magnitude of a minus b, which is 1. And this is always a there and there. And then I'm going to sketch my circle, which is symmetrical about the initial line. So it's going to look like that, going through 0, 0. Okay. And it's going here through, well, I know that cos of 0 is 1, so it's going to go through 5 there. Okay. So I want to find the area bound by these two curves, so trapped between these two curves. And that is going to be this area doubled. So this entire section here. And so what I will need is I will need to find, I'll have to think about this carefully, because this is not as straightforward as the previous one, because it involves two sections. It's going to involve this if I start measuring at theta equals 0, all the way, if this line r continues all the way up to there. So whatever the theta value at that point of intersection is, that's the angle I want. And then I also want, let me use this color. From there, I need this section here. I don't know if you can see it very well. I need a brighter color. Let's use green. I also want this area here. So that section there. It's going to be first section doubled, first area, and then it's going to be that area doubled. So I'm just going to, key thing, I'm going to write this out in a minute, but I will need this point of intersection. I'll need the point of intersection. This is going to give me, this is going to be area 1. I'm going to call this A1, and this green is A2. And I will need 2 lots of them, and I will need 2 lots of A1. But the first thing I will need in order to find that is I will need the points of intersection, because I will need that angle. And just to explain this again, my initial line will start at theta equals 0. Theta equals 0. It's going to go all the way up to there, whatever that angle is, and then it's going to continue. Theta is just going to continue until it gets to pi by 2. So I know by the time it gets this, what was the purple curve, which I've now written over, by the time it gets back to here, right, that's going to be when theta is equal to pi by 2. So whatever this theta value is here, let's say theta is equal to alpha, I'm going to integrate between 0 and alpha of the between 0 and alpha of this curve, 2 plus cos theta, and I need 2 lots of them. And obviously it's that squared, and I need my half there, plus 2 times a half of the integral between alpha and pi by 2 of 5 cos theta, all squared. So that's what we're trying to find. I hope that makes sense. Okay, so let's have a look. We're going to start the second bit. We've done lots of drawing, but now let's find the points of intersection. Let's label that point of intersection. And so I'm going to equate 2 plus cos theta equals 5 cos theta. When I rearrange this, this gives me 4 cos theta equals 2. So cos theta equals a half. Okay, well, let's solve that. So when I use my calculator to work that out, I get theta is equal to pi by 3 or minus pi by 3. 2 solutions. I then go and sub this in to find my R value, because I'm asked for my points of intersection. So I need an R value there for pi by 3, and I need an R value there for minus pi by 3. We know that R is equal to 2 plus cos of theta. So when I sub in pi by 3 and minus pi by 3, well, I get the same value, a half. I know that from here. So R is equal to 2.5 in each case, or 5 over 2. Okay, so those are my points of intersection. This will be 2.5 and negative pi by 3, and that's going to be 2.5 and positive pi by 3. And so now I know that alpha is equal to pi by 3. Okay, so let's go and write out this area sum that we're working on. I've got 2 times a half of the integral between 0 and pi by 3 of 2 plus cos theta all squared, plus 2 times a half of the integral of 5 cos theta all squared d theta, and this is going to be between pi by 3 and pi by 2. Okay, So very nicely, in each case, obviously the 2 times a half will simplify and cancel down. So I'm going to end up having, let's just work this out step by step. It's going to simplify to the integral between 0 and pi by 3 of 4 plus 2 times cos theta times 2, so 4 cos theta, plus cos squared theta. And you've hopefully memorized that cos squared theta is 1/2 plus 1/2 cos 2 theta. Obviously, we should do in the exam, we should do this bit of working on the side here, just to keep our thoughts organized. So I'm going to add that in there, plus 1/2 plus 1/2 cos 2 theta. And to this I'm going to add the integral between pi by 3 and pi by 2, and this simply squares to 25. So I'm going to take the 25 out to the front. And again, I've got cos squared theta. So it becomes 1/2 plus 1/2 cos 2 theta d theta. And now I can continue with my integration. So I will have, well, 4 plus 1/2 is 4.5, so 9/2, which I'm going to integrate, and that gives me 9/2 theta. 4 cos theta becomes plus 4 sine theta, and 1/2 cos 2 theta becomes 1/2 sine 2 theta divided by 2, so times by 1/2. So I get 1/4 sine 2 theta between 0 and pi by 3. On this side, I'm going to factor out 1/2. So I'll get 25/2 on the outside. And I'm left with 1, which integrates to theta. And my cos 2 theta becomes 1/2 sine 2 theta. And that's all between pi by 3 and pi by 2. Okay, so there we go. We need to now sub in our values here. And that's going to give me, if I sub in pi by 3 there, I'm going to get 27/6 pi plus 4 times by sine of pi by 3. Sine of pi by 3, which gives me √3/2, plus 1/4 times sine of 2 pi by 3, which gives me √3/2. So that's my first bracket, and then when I sub in 0, I just get 0. Okay, and then I'm going to get 25/2 here, and when I sub in pi by 2, I get pi by 2 for theta, plus 1/2 times, well, 2 times pi by 2 gives me sine of pi, which is 0. So that's 1/2 plus 0, minus pi by 3 plus 1/2 times sine of 2 pi by 3, which we also just worked out was √3/2. Okay, and now I just need to tidy this up. 27/6 is going to give me 9/2 pi. 4 divided by, so that gives me 2√3 plus √3/8. And then over here I've got plus 25/2, and that gives me, if I simplify the brackets, I've got pi by 2 minus pi by 3, which is going to give me pi by 6. And then I've got, not plus, I've got minus √3/4. So let's now simplify this. This gives me, I'll have 9 by 2 pi plus 25 pi by 6. So that's 9/2 plus 25 divided by 6, which gives me, sorry, not 25 divided by 6, it's obviously 25 divided by 12. Hang on a minute. Let me write this down. 9 over 2 pi, and that's 25 pi by 12. Just realized there is a little mistake here, and that actually if 9 by 2 and I sub in pi by 3 is obviously going to give me 9 pi by 6, which changes things slightly. That's 9 pi by 6. So then I've got 9 pi by 6 plus 25 pi by 12, which is, I'm just going to work this out here, is going to give me 43 pi by 12 minus root 3. And that there is the correct answer. Okay, so just be careful with your simplifying. Easy to make a little mistake. Always check the final answer on your calculator. So in the third example, we are looking at finding the area of one loop of the curve r equals a sine 4 theta. So we know that n theta determines how many leaves there are in the polar curve. That is, if n is even, then I will have double the amount. So in this case, I'm going to have 4 times 2 loops or leaves in this curve. So I need to find the period for which this is happening. So I'm just going to say in total 2 pi divided by 8 is going to give me pi by 4. So I know I'm going to have to integrate. I have to say a half times a sine 4 theta all squared between 0 and pi by 4. And that is going to give me the area that I'm looking for. So what I'm going to do is I'll square this and I'll take my a squared to the front. And I'm also going to rewrite sine of 4 theta as a half minus 1/2 cos of 8 theta. Sorry, that's obviously sine squared 4 theta. And that's what I get, a half minus a half cos 8 theta. Okay, so I can add this here. And then I'm going to do my integration. A squared over 2, a half integrated gives me a half theta, and minus a half cos 8 theta is going to give me minus 1 over 16 sine of 8 theta between pi by 4 and 0. And then if I sub this in, get a squared over 2, I'm subbing in pi by 4, so I get pi by 8. And if I sub in pi by 4 there, it's going to give me 2 pi, which is 0. And then when I sub in 0 into both of those terms, I just get 0. And so my final answer for this question is a squared pi by 16. There we go. So the only thing here to remember is it's really easy to determine where you are integrating between if you just divide the period by how many loops there are. Okay, I hope that was useful. As always, if you have any questions, please do let me know.